Okay, so here we're going to take a short look at a more formal introduction to the straight line topic that we've already been looking at. So far we've looked at linear patterns and how we can create them. We've looked at what happens when we try and draw them, and now we're going to define it a little bit more formally. What we're going to say is that actually, whenever we've got a linear pattern, they are always going to produce a straight line shaped graph. Okay, and in order for them to do that, they are always going to take this form of y equals mx plus c. So what we can do from this is we can take some really important bits of information. Okay, now important to point out that just now the type of graph we are interested in is the one that gives us a straight line. Okay, now there are others that give us different types of shape, and as we move kind of up part of the year groups, we'll start to look at different shapes and different ways of spotting them and how they can be used. But just now, all we are interested in are the ones that give us straight lines, okay, our most basic of shapes. When we have it written in this form, there are a couple of really useful things we can take from it. So this is y equals mx plus c. The m here tells us the gradient of the line. Okay, so again, remember the gradient is just the steepness of the line. This plus c bit here tells me the y-intercept. Okay, and what do we mean by that? Well, if we were to draw out some axes, and we draw our straight line on it, then my y-intercept is that point there where it cuts the y-axis. Okay, so they're two pretty useful things. Okay, and from those two numbers we can tell a lot about it, and we'll do that moving forward. But just now, all we're going to do is practice making sure that we can interpret the numbers from the equation. Okay, so all we're going to do is we're going to look at writing down the gradient and the y-intercept of the following lines. So the first one, I want to check and see, is it in the form y equals mx plus c? Yes, it is. Something times x plus the y-intercept. So what was my gradient? Given it m, that's the letter. And so matching it up, gradient here is equal to 2 c, the y-intercept is equal to 1. And all we had to do was write the numbers down. Okay, we're not asked to say how we know that. We're not asked to do some kind of elaborate way of solving it. We just have to write the numbers down. So for the second one, again, matching it up, y equals mx plus c. So my gradient is equal to 4. My y-intercept is equal to 2. Thirdly, okay, again, y equals mx plus c. So m, my gradient, is 0.5. C here is equal to 1. Interestingly, we don't really know why we use m to stand for gradient. In terms of letters, you'd think we'd use g, but the physicists already took that to mean gravity. So the best guess we've got is that actually we took it from the French word monter, M-O-N-T-E-R, which is just the French verb to climb, and we think that's where it came from, but no one's really very certain. But m is the letter we've decided to use to denote gradient. So there you go. C, we use c for the y-intercept because we use c short for constant. It's just a number. The number doesn't change. But the other bit might. When you put a number in, it's going to change the values that it gives you, but you're always going to have to add on 1 in this case. That plus 1 bit doesn't change in your equation. That's where the c comes from there. So, lastly, let's check and see y equals mx plus c. Does it match? What's my gradient? This time is equal to -3. I have a y-intercept. Well, I don't have anything added on, so the y-intercept here is just 0. And lastly, can I work backwards? So if I have the gradient and the y-intercept, can I put that back into an equation? Well, yes, I can. If I know it should take the form y equals mx plus c, I've got a gradient of 3 and a y-intercept of -5. So my gradient was 3, my y-intercept was -5. That means I've got y equals 3x minus 5.